Hey there, hi there, ho there. Welcome to Unit 3. Earthquakes. That was me shaking because that was an earthquake. Let's jump into this. So kind of, working from the inside of the Earth out. These first hazards that we will deal with are manifestations of what's happening internally in the Earth and what that's causing externally. In this case, earthquakes. This is a great place to start. So just some basics. Excuse me. So movements within the Earth's crust, as the plates kind of jostle around, movement within the Earth's crust causes rocks to deform, bend. Yes, rocks can bend quite easily because of the high amounts of force and stress on the plates as they're jostling around. So when, for instance, this looks like a convergent boundary, kind of what we talked about last unit. So we have some some plate converging and then subducting down. As it does, as that plate is converging and coming down, it kind of takes that overlying plate with it and kind of bends it down with it. And in doing so, you really start to store up energy. It's almost like kind of, look at this. It's almost like this rigid ruler. Rocks are rigid, but with this ruler, I can bend it. I'm storing energy because when I release it, it snaps right back. Well, kind of the same thing in plate tectonics and when earthquakes occur. So when the stress finally exceeds the strength of the rock itself, the rock can fracture and might slip along those fractures, which create an earthquake because you're releasing tension, you're releasing pressure and energy, causing an earthquake. Or the plate itself, maybe it might not crack, might just snap back, kind of just like this ruler. It might just snap back up, rebound, and that stored energy is also suddenly released. And these occur along a fault line. More on those in a moment, but in general, a fault is any large portion of Earth where there is movement between two different sides of rocks. And that could be at a break-in movement or the snapping back because you get this large plate movement, large rock movement occurring. More on that in a little bit. So when an earthquake occurs, the energy is released as what's known as the focus of the earthquake. Energy is released in the form of seismic waves that spread out in three-dimensionally all directions to the surface, in fact, even through the Earth to the other side of the Earth. So they can travel in large distances in all directions. If there's an earthquake on the other side of the Earth in Japan, we can detect it here because those seismic waves travel through the Earth. So again, we have where the earthquake occurs, the point of the initial breaking or rupturing within the Earth along a fault line where there's movement. That's called the focus. So that's where the earthquake starts. It's where the kind of the energy is released from, where the seismic waves emanate from. And then you might have heard this term on the news or on a movie or something like that. But there's also something called the epicenter. The epicenter is just a fictitious point on the surface of the Earth directly above the focus, directly above where the rupture and energy is being released took place. So the epicenter is just a fictitious point on the surface of the Earth directly above the focus. Now, it is the epicenter of the earthquake that would receive the most damage because it's directly above it. It's on the surface. And then the amount of damage, the further you get away from the epicenter, decreases. As far as faults are concerned, and they're everywhere. There's a lot of places. Some of them don't move anymore, some still do. So most geologists consider a fault to be an active fault if it has moved within the past 10,000 years. So there may not even have been an earthquake for 9,000 years, but since there was within 10,000 years, it's still considered active, meaning it could still, in a high likelihood, have some movement along that fault to create an earthquake. The reverse of that, faults that have not moved in 2 million or more years are generally classified as inactive. The chances of them ever moving and releasing energy again and causing an earthquake are almost zero. And then you have kind of the in-between 10,000 and 2 million years. Faults are considered dormant, and they're kind of sleeping. They could come back, but the high likelihood is like 50-50 shot. So where do earthquakes occur? If you remember a little bit from last unit, lecture, discussion, etc., the place that they most often occur is at or around plate boundaries. Not always, but at or around plate boundaries. So the pink lines are plate boundaries. This map is actually a little off. I don't know why everything's a little off. But in any case, but in general, you can see that the yellow or orange dots indicate earthquakes, and most major earthquakes that you see are at or near a plate boundary. Every once in a while, you get some random ones away from plate boundaries. Every once in a while, you get some random ones, away from plate boundaries. More on those later. But generally speaking, most earthquakes happen near plate boundaries. They don't necessarily always have to, but now, generally speaking, the active faults are at or near plate boundaries. That's where most of the movement and interacting is going on. So again, most earthquakes occur along or near plate boundaries, and that's in contrast to something called an intraplate earthquakes. Intraplate earthquakes are in the middle of plates, not kind of near plate boundaries. These are earthquakes that are kind of in the middle of the plate where there is no boundary. These are infrequent, but they occur nonetheless. Maybe there's some old ancient fault that just every once in a while moves. Because earthquakes really occur along a plane of weakness in the Earth's crust, again, known as a fault, which faults are areas where there's breakage and or slippage and movement of two rock surfaces. Obviously, that's what happens along plate boundaries. But again, however, sometimes earthquakes occur away from plate boundaries. Sometimes breaks and faults can occur in the middle of plates, causing faults and earthquakes far from plate boundaries. Those types of earthquakes, again, known as intraplate earthquakes. So, for instance, looking at some historic earthquakes that happened in the Midwest here, way far away from a plate boundary, these are known as intraplate earthquakes. Some breakage and movement underground causes some rock surfaces to move relative to one another, causing an earthquake. Not unlike what you see in some of these other locations away from plate boundaries. As far as Arizona is concerned, this is just a map that shows in blue some known faults. Excuse me. And in green, known historic earthquakes above a certain magnitude. More on magnitude later, so it's not important. But anyway, the blue indicates faults, the green indicates known in historic earthquakes, as tracked by the AZGS, the Arizona Geological Survey. That's the state's geologic entity. Looking in the Phoenix area, we don't usually have... Oh, by the way, this is where earthquakes, where the focus of the earthquake is below the surface. We don't have really earthquakes occurring in Phoenix, close to Phoenix. Like, they're not happening below our feet, but we feel them all the time. From as far away as California even, we can feel the earthquakes happening from time to time. But again, Tucson, there's really none that's happening directly under Tucson, but there have historically happened in proximity. But if you look in Flagstaff, though, for sure. In fact, the main amount of faults and earthquakes occur in this known as the Arizona seismic belt. So a lot of stuff, a lot of movement of faults, a lot of movement of rock along faults to create earthquakes. So these are all earthquakes that, again, began underneath Arizona in these locations. They're not crazy huge earthquakes like what we think about with California and other places, but they do occur nonetheless. Kind of looking at a terrain map of Arizona and kind of looking where this is, kind of along this area. This area where we're going from kind of more flat desert up to high mountainy areas. So we have a lot of earthquakes in this area, and then also there's a lot of volcanoes in these areas as well. So where you have volcanoes. You have, movement of material that causes earthquakes. You have ancient faults, things move, earthquakes. So what are some major and or recent Arizona earthquakes? So on the major aspect of things, in 1887, so 140 years ago, a magnitude 7.6 earthquake near the Arizona-Mexico border, kind of just south of Douglas, which would be behind my face here, actually. Yeah, so right down here. Here it is. So Douglas, Arizona is here. So in 1887, magnitude 7.6 earthquake. It's a big earthquake. More on that number later. Killed 60 people. Felt throughout the U.S. or throughout the Southwest, Tucson, up into Prescott, over into Albuquerque in New Mexico, and El Paso, and down into Sonora, Mexico. So that was a major one. Flagstaff. 1906, 1910, 1912, a little over 100 years ago. 3 moderate-sized earthquakes, 6.0 to a 6.2 rattled Flagstaff, widely felt throughout northern Arizona. So a little more recently, 1976, less than 50 years ago, a magnitude 5.0 earthquake occurred near Prescott, Arizona. 1993, back up again in this seismic belt. The Cataract Creek earthquake sequence. So you had several earthquakes occurred in a swarm event, so kind of one after another, including a magnitude 5.4 and a magnitude 5.0 on the Richter scale, just south of the south rim of the Grand Canyon. So the Grand Canyon's right here, so these earthquakes were just south of that. More recent felt events include in 2005, magnitude 5.2 near Holbrook, a 5.3 near Duncan in 2014. In 2015, there was a magnitude 4.1 near Black Canyon City, which shook Phoenix and was perhaps felt by millions of people. There's also been more recent ones in Mexico that we have felt in Phoenix. I have definitely felt some earthquakes at my household in the past 7-8 years. One. Well, I'll save how I knew that for a later time. But in any case, a little bit of basics about earthquakes. It requires some break in movement or just general movement between two different rock surfaces for energy to be released in the form of seismic waves. And that's what we feel. And that's what's the earthquake. Focus, underground, epicenter, above ground. Usually happen near plate boundaries, but every once in a while they can happen away from plate boundaries, known as intraplate earthquakes. And they do occur in Arizona, and even though they don't occur under Phoenix, historically speaking, doesn't mean they couldn't, but we definitely do feel them as they occur near where we live. So let's go ahead and pause here. When we come back, we'll talk about the different types of faults, what's more likely to give us earthquakes, bigger earthquakes, etc. But before we do, let me give you the first part of the super secret code. It is the number 6. You got me? The number 6. One more time, the number 6. I'll see you back here in just a second.